Hello, everyone. This video will be going over our Algebra 2 Chapter 3 test, going over equivalency and rational expressions. Number one, read. For each of the following expressions, find at least three equivalent expressions. This lists each different form in the space provided. Again, we're going to be looking at different forms. And for A and B, we have three spaces for you to put your equivalent expression. So, looking at A, we are given the expression 2x minus 5 squared minus 8. What I am expected to do here is to find a different form of this expression that is still equal to this expression. So I'm changing the form, and the way I'm going to do that is by simplifying. So the name of the game for both of these is going to be to simplify. The way we simplify is going to take two different forms. So simplifying for our value A, or our expression A, is going to be using PEMDAS, or order of operations. I'm just going to go through our operations and see how far I can get. So, first things first, I look at my parentheses, x minus 5. Now, I cannot combine x minus 5, they're on my terms. So, as far as simplifying whatever's inside my parentheses, I cannot go any further. I'm done with my P, or my PEMDAS. Looking at E, however, I do have an exponent, so before I do anything else, I must resolve this. The way I do that is by expanding out what the exponent means. So the exponent does not apply to the x or the 5, it applies to the whole parentheses. So the way I write this out is going to be 2x minus 5 times x minus 5 minus 8. And from here, I'm already have an equivalent expression. This form is different from what I originally had here. I significantly changed it. The types of change I'm looking for are using your exponential rules by multiply, dividing, distributing. The main thing you want to be careful of is simplifying via addition and subtraction. As I said previously in this course, this is an Algebra 2 level course, so we are expecting Algebra 2 level work. And generally speaking, merely adding and subtracting two different terms doesn't rise to the level of creating a new equivalent expression in Algebra 2. With that being said, this absolutely does. This form is different from this form, so I'm going to count that as my first equivalent expression. So that's going to be 2x minus 5, x minus 5 minus 8. Now, from there, I'm not done with my order of operations, but I am done with all my exponents. There are no more exponents. So from here, I'm free to multiply and divide. Multiplication and division are done simultaneously. But in this case, they have no division, and multiplication order doesn't matter. So I could go about this a couple ways. I can distribute my 2, multiply my 2 into one of my parentheses, or I can multiply my 2 parentheses and then distribute my 2 after. I'm actually going to distribute my 2 first. And know what I said earlier, I could distribute my 2 to one of my parentheses. I cannot double up on my 2 and multiply into both my parentheses. This 2, there's only one of them, so I can't double up and create another 2 to multiply into this one. One value of 2 only goes into one of my parentheses. So make sure not to double up any values you have. But if I do, that would be 2x minus 5. 2 times 5 is 10. So 2x minus 10 times x minus 5 minus 8. And once again, I said by distributing and multiplication, you create a new form. So we're going to count this as a new form. This is going to give me 2x minus 10, x minus 5 minus 8. And from here, I could multiply out my two parentheses now, which will indeed give me a new form from there. So I'm going to write 2x negative 10. I'm going to have x minus 5. So that's going to be 2x squared. That's going to be negative 10x. That's going to be negative 10x. And that's going to be positive. I don't need the plus there necessarily. But what my result gives me is 2x squared minus 10x, and negative 10x gives me negative 20x. plus 50 minus 8. So this, once again, will constitute a new form. I multiplied out my two parentheses, and I got this. The result gives me a new form. This form looks very dissimilar to this form, but we know that they're equal because we're just simplifying going through the math. Everything is still equal. All these different steps are still equal. But before I write this in as my answer, I'm actually going to do one more thing and just simplify my 50 and -8. So what this is going to give me is 2x squared minus 20x plus 42. Now, from here to here, this does not constitute a new form because what I said is addition, just adding and subtracting two numbers doesn't rise to the level of getting a new form or equivalent expression in Algebra 2. Are they equivalent? Yes. But again, this is an Algebra 2 course, so we're trying to see whether or not you're able to do Algebra 2 level work. So we're just trying to recognize and push you guys to change the expression significantly. And this, I would say, is a new form compared to the other two that we've already had. So this will be my third and final answer. This is going to be 2x squared minus 20x plus 42. Now, these are not the only three answers that I would accept. Like I said previously, you could have done something different at this step. So let's go ahead and explore what that would look like. I erased all this, gives me room to show you that step would have been, or what that uh, step would have given you. So I erased all this. Forgive me, I'm trying to save my editing time down later. Right here, I said I could have multiplied out my two parentheses. And what I would have gotten was, and we do our side work in red. If I did x and -5, x and -5, this would give me x squared, -5x, -5x, and positive 25, which then would have given me 2x squared, -5x, and -5x give me -10x plus 25 minus 8. This would have counted as a totally new form, as would have distributing my 2 at this point, which would give me 2x squared minus 20x plus 50, if that makes sense, minus 8. This and this would have counted as different forms because, again, we're getting these from our original. We just went a different route, but you'll notice that these forms are different from the forms that I put down here. So there are a multitude of ways that you could have done this. You could even, at this point, if you didn't recognize some of your forms, could have written as 2 times x minus 20x plus 42. You could have factored out a 2. It could have been 2x squared minus 10x minus 21. You could have done a lot of things. All I'm saying is that you could get creative with this using your order of operations and your exponent rules to give me a multitude of different forms. But these are just a few examples of what they could have looked like. Again, I'm just looking for 3. So if you just give me 1, 2, 3, that's absolutely enough. I'm just going over it in more detail so you could see what I was asking for and looking for in this question. Looking at part B, the name of the game is still simplification, but here I want to use the rules of exponents to expand and then to cancel. And looking at my expression here, it's kind of a mess. I have a lot of different values. So rather than trying to work with all of them initially, I'm going to try and simplify it to make this a little bit simple or simpler. Simple or sounds weird. Yeah, I'm trying to simplify this. So the way that I do that is by breaking up my components. I'm going to break up my number parts, this being 3 over 12, my x part, x to the third over x to the fifth, that being my y part next, that being y to the third all over y, and z. There is no z in the denominator, so I'm just going to put it over 1. All I've done at this point is just separate all my components so that I could then cancel to make this expression easier to work with. So looking at 3 over 12, well, I recognize that 3 and 12 are both part of the 3 multiplication fact family, which means I have a 3 in common, so I could divide out a 3, giving me 1 over 4. Looking at my next part, I have 3 x's on top, 5 x's on the bottom, which means that I could cancel 3 of them. So I'm going to go ahead and cancel out this, and I'm going to cancel 3 of my bottom x's, meaning I have 2 left over, meaning I'm left with 1 over x squared. Now, the placement of these exponents, the places of these variables is very important. We had x's left on the bottom, on the denominator, so you must make sure that your x's stay in the denominator when you are done simplifying. Similarly here, I'm going to cancel a y here and a y here, meaning I only have 2 y's on top. So that's going to be y squared in the numerator, while all my y's on the denominator cancel. And of course, I only have a z left. That's going to be z over 1, which is going to give me y squared z all over 4x squared. And already through the process of simplification, I already have one equivalent expression, that being y squared times z all over 4x squared. And at this point, now we just need to rely on our exponential rules, what we remember about exponents. The easiest way to create an equivalent form is first by expanding out. So I have 2 y's on the top. That's what my y squared represents. So I'm just going to write that out in expanded form. It's going to be y times z all over 4 times x. This is all counts as an equivalent expression. We're changing it from exponent form to an expanded multiplication form. Now, another way we could rewrite this is, let's say, well, I have 2 squares. So let's take y over x, take the square out of both of them, put it in parentheses, and multiply what's left over z over times z over 4. And that would be equivalent. The whole idea is that however you rewrite the expression, you must make sure that it matches the original. It must have 2 y's, 1 z, a 4, some representation of that 4, and 2 x's. Now, some creative solutions that I like are if I write 4x squared all over y squared z, all to the power of -1. That's implementing our negative exponent rule. Another way that I saw this done was uh, if we had, some people included some other y values. So if we had y to the fifth all over y to the third times x to the seventh, x to the fifth, just again, knowing that these cancel and you would still have x squared and y squared. And let's say that we had z to the third all over z squared all over 4. Let's not mess with that 4. But again, if we cancel this, that's going to be y squared. That's going to be x squared on the bottom and z on the top, and we're left with 4. Again, all you're trying to do is make sure that your exponents or your exponential values match your simplified version over here. That's what it means to have equivalent forms. Now, you could expand it, you could play around with it, you could rewrite the form, or you could create your own expression by introducing these new values, so long as that they cancel back to our simplified form here. Okay, with that in mind, that goes over problem number 1. Simplifying in 2 methods. If it makes sense, great. If not, please make sure that we come to class with the tutor with some questions. and I'll be happy to explain more in detail then. Looking at number 2, it tells us decide whether each of the following pairs of expressions are equivalent. They are equivalent. Show how you can be sure. They are not. Justify your reasoning completely. Uh, Once again, the name of the game is going to be to simplify. If I simplify both sides, it'll tell me whether or not they are equal. So looking at part A, I'm going to start working off my left side. I have two parentheses being multiplied. I'm going to multiply those out. That's going to give me x and 5, x and 1, and I create my multiplication box. X times x gives me x squared, 5x, 1x, and 5. This gives me x squared plus 5x plus 1x plus 5, then giving me x squared plus 6x plus 5. And from this point, I can simplify no further. So if I'm done with my left side, let's look at my right side. Once again, I have two parentheses. This squared applies to the whole thing. I'm going to rewrite this as x plus 3 times x plus 3 minus 4. Multiplying these two parentheses out gives me x and 3 gives me x squared, 3x, 3x, and 9, giving me x squared plus 3x and 3x makes 6x plus 9 minus 4. Now, many of us stopped here at this point and said that they are unequal. However, there's no more need for these parentheses. There's no more multiplication and division, and I cannot simplify this any further. So from here, I could just treat this as x squared plus 6x plus 9 minus 4. And there's nothing stopping me from subtracting this 9 minus 4. In turn, will give me x squared plus 6x plus 5, making these two equal. So again, you want to make sure that on your work, you want to say the emphatic yes, they are equivalent. And you just showing will work will be enough justification for that. Looking at part B, if we multiply this out, again, this power applies to the whole parentheses. Excuse me. That's going to give me x minus 8 times x minus 8, which is going to in turn give me a small box, slightly bigger. That's going to give me x squared, negative 8x, negative 8x, and that's going to give me positive 64. Negative 8 times negative gives me positive 64, meaning I have x squared minus 8x minus 8x minus 64. Now, I want to highlight this part for a moment. Negative 8x minus 8x do not cancel. You subtract them, and if you subtract the negative into the same sign, you combine the values and it remains negative. What would cancel is negative 8x plus 8x. In order to cancel to make 0, one needs to be positive, one needs to be negative. When I have two negative values, they just add, and that's going to be x squared minus 16x minus 64. And now, I can simplify this side, but I could factor, I could play around with it. But you'll notice these already share the same form. I have an x squared, I have a minus 64. Ooh, as a matter of fact, it should be a plus 64. I have an x squared, and I have 64. But there's two significant differences. One being, this has a negative 16, this does not. And this 64 is negative, well, this one is positive. Now, because they are both in their simplified forms, that's enough for me to go off of to state that no. State that No, they are not equivalent because the 64s are different signs, and one has a negative 16x while the other one doesn't. So long as your explanation looks something akin to this, or you circle the parts that are different, I will give you credit. But this is going to cover number two, A and B for our question, our unit, or unit assessment. That tackles number two. Looking at problem three, it reads, simplify the given expressions. For part C only, state any values of the variables that would make the denominator zero. Once again, this is our factoring game. So I need to find a value that multiplies into 16 that adds up to be negative 8. So I go through my 16 facts and I realize that, hey, 4 and 4 multiplied 16 give me 8. I want a negative 8. So I test negative 4 and negative 4. Negative times negative gives me positive. So that's leaving positive 16. This will add up to be negative 8x, meaning I have a combination that works. So we're doing my factor box. That is going to be x squared and 16, negative 4x and negative 4x. This gives me x minus 4 and x minus 4. So this top part, this numerator, can be rewritten as x minus 4, x minus 4, or in other words, x minus 4 squared. But for right now, we'll leave them as two separate parentheses. Now, looking at my bottom, look at my denominator. You'll notice I don't have a middle term. However, just because I don't have a middle term there doesn't mean I don't know its value. So whenever you have a binomial, you only have two terms, I want you to test two things. One, is there anything that gets factored out? Looking at x squared and negative 16, do they have anything in common? The answer is no, they don't have anything in common. But when that fails, what I want you to try is test our middle value as 0. So x squared plus 0x minus 16. I have a third term now. Does it become factored? And the answer is yes. Negative 16 breaks up into negative 4x and positive 4x. So I could have my x squared negative 16. And since it's negative, I can make one of my 4's positive, one of my 4's negative, and a positive 4x and negative 4x cancel to be 0. So this combination works, giving me my parentheses x and 4, x and negative 4, meaning my denominator will be x plus 4, x minus 4. And from this point, all I need to do is cancel. I have an x minus 4 on top, x minus 4 on the bottom. They cancel, leaving me with my final answer, x minus 4 all over x plus 4. And that completes my problem A. Looking at part B. So I could factor this as is, but what I want you to immediately notice is that all my terms have something in common. I have a 5, 35, and 60. Those are all part of my 5's fact families. So what that means is I could take a 5 out of each of these terms. So what I'm left with is 5x squared. 35 divided by 5 is 7x. And 60 divided by 5 is 12. Similarly, you'll notice that I have a 20 in common with both my terms. Not just a 20, but a 20x, meaning that I have x plus 3 left over here. So now that I have taken out what's in common between these two expressions, now I'm going to go about factoring. So looking at my numerator, I can factor this by doing my box, and this will give me x squared and 12. And I'm looking for a combination that adds up to be 7x, and I know that 3 times 4 gives me 12, and 3 and 4 add up to be 7. So I found my combination, giving me x and 3, x and 4. So this is going to be 5, x plus 3, x plus 4, all over 20x times x plus 3. And from here, so we have some things in common. I can cancel my x plus 3 and x plus 3. But what some of us forgot, then I want you to be able to recognize, is that just because we're canceling expressions and, canceling our binomials, canceling our parentheses, doesn't mean we can forget about our numbers. 5 and 20 do have something in common. So when I cancel these, I'm take a 5 out of 5, I take a 5 out of 20. 5 divided by 5 is going to give me 1, and 20 divided by 5 is going to give me 4. I'm left with a 4. I have nothing more to cancel, so my answer is going to be x plus 4 all over 4x. And that is my answer to my second one. Moving on to part C. We have once again a numerator and denominator. Now, something I noticed some of you doing. You do not need to multiply these out. Yes, this simplifies to be x plus 3, x plus 3, and x plus 3. But I don't need you to multiply these out. You just leave them as parentheses. The whole name of the game is trying to cancel. And when you have them in their factored form, in their parentheses form, that makes it easier to identify parts that I could factor. So all I need to do is factor my bottom part. So this case, I would start with my box. Gives me x squared and 24. I'm looking for a combination of what times what gives me 24. That will give me 5x. And the combination that is going to work should be negative 24. Negative 24, I get negative 8 and 3, which will give me negative 5. So this combination works. I'm going to put in negative x, 3x. It's going to be x and x is meaning negative 8. And this is going to give me 3. Meaning that my denominator is going to become x minus 8, x plus 3. And what do you know? I can cancel. Now I can't cancel any further, so my answer here is going to be x plus 3. Could rewrite this as 1 parentheses squared all over x minus. And as far as simplifying, I am done. Once again, I remind you down here that for part C, I need to state any values of the variables that would make the denominator 0. So I don't just look at my final piece, I need to look at all steps. So this intermediary step where I have x minus 8 and x plus 3, I must test both of those. I don't want my denominator to be 0. So x minus 8 cannot be 0, and x plus 3 cannot be 0. Which means that in this case, x cannot equal 8, and x cannot equal to negative 3. Fully completing my part C. Looking at our final question, number 4, it says, multiply or divide the expressions below. Leave your answers as simplified as possible. We're trying to cancel as much as possible. Looking at part A, we have 4 components, and we need to factor each of them. So let's get straight down to business. So let's go ahead and see if we could box this off, make this a little clearer and cleaner for us. So this is going to give me my box of x squared, and 6. And I want my values to add up to be 5. Well, I know 2 times 3 gives me 5. 2 and 3 add up to 5, multiply to 6. So my combination works, giving me x and 2, x and 3, which gives me my two parentheses, x plus 2, x plus 3. The better your factoring skills are, the faster this question goes. It's a lot of components, but it's just factoring. So long as we're doing our factoring and understanding our factoring skills, hopefully this won't be much of an issue. Now I'm going to look at my denominator. That box is going to be, let me make such a tiny box. That's going to be x squared, and I want positive 10. Now, I know that 2 times 5 gives me 10, which would give me 7. But since I want a negative 7, I need to make both of these negative. That would give me negative 2x, negative 5x. It'll be x and negative 5, x and negative 2. Meaning this ends up being x minus 2, x minus 5. Look at my numerator here. This is, again, they don't have anything in common, so I'm going to test my zero rule. I'm going to test x squared minus plus 0x minus 25. And thankfully, 25, if I break up 25, that gives me negative 5x and 5x, which will end up canceling to be 0. So if I use those values, it's me 5x and negative 5x. That's me x and x, negative 5 and 5, meaning this ends up being x plus 5, x minus 5. Okay? And finally, we have x squared, and we have 15. Naturally, 3 and 5 make 15, which also gives me 8. So I have 3x and 5x, give me x, x, 3 and 5, giving me x plus 3, x plus 5. Phew, the hard work is done. Now I just need to put it together and cancel. So looking at all my components, I'm going to have x plus 2 times x plus 3 times x plus 5, x minus 5, all over x minus 2, x minus 5, all over x plus 3, x plus 5. Now, I can only cancel from numerator to denominator, but I can cancel up and down or diagonally. So I'm just looking at my numerator denominator, see if there's anything in common. And the first thing I notice, my x plus 3s aren't the same. Then I notice my x plus 5 are the same. And the one that might not be super obvious at first is my x and minus 5 and x minus 5 can also cancel, meaning that my final answer is going to be x plus 2 all over x minus 2. And I am done with part A. A lot of factoring, a lot of canceling, but all in all, this is our answer. Looking at part B. Now, first thing I want you to notice is that we are dividing here. And we're dividing fractions. You must keep, excuse me, you must keep, change, and flip. One last thing is I told you guys during the test that rather than a minus 24, I want you to treat this as a plus 24. If you didn't, no worries, I took that into account. But I did remind you during the test that there was a typo, so that we're going to treat that as a plus 24. That being said, when we keep change flip, rather than rewrite the whole thing, I'm just going to annotate. So this division is going to turn to multiplication. And I'm going to treat this as x minus 9. I'm going to treat this as, across the other one. So I'm going to treat this as x minus 9. I'm going to treat this as x squared minus 10x plus 24 because I have to keep change flip my fractions in order to keep my work being correct. In order to divide two fractions, you have to multiply the reciprocal. Strategy we use is keep change flip. So you keep the original fraction, you change the division to multiplication, flip your second fraction. So we have a little less room to work with, But essentially, we're going to be doing the same thing. We just need to factor and simplify our four components, our two numerators or two denominators. I'm going to treat this as x squared minus or plus 0x minus 16. And what I get from this is x squared and 16. I know that negative 16, I can break that into 4 and negative 4. That cancels to be 0, so I have my combination. So this is going to give me x plus 4, x minus 4. And I get that from the outside of my box here. Now, this box is going to be for my numerator for my second fraction. So that's going to give me x squared plus 0x minus 9. Again, whenever I have uh, two terms, whenever I have binomial, I want to test to see if I can get my 0 value to work in the middle to be my middle term. And negative 9 breaks up to be 3 and negative 3, which means that, yeah, they do indeed cancel. So this is going to be 3x, negative 3x, meaning I get x and 3, x and negative 3, giving me x plus 3, x minus 3. And that's the parentheses for our second numerator. For our first denominator, that box is going to give me x squared and negative 3. Now there's only one combination that works for negative 3, that means 3 and 1. And if I want a positive 2, make my 3 positive, my 1 negative. Give me x and negative 1, 3. Give me x minus 1, x plus 3. And finally, our last expression we need to factor, that is going to give me x and 24. Now I want a negative 10, and the combination that will give me that is going to be negative 6x and negative 4x. Negative times negative gives me positive, so there's no issue there. Of course, this should be an x squared. This gives me x minus 6, x minus 4. That's going to give me x minus 6 and x minus 4. So from here, again, all I need to do is rewrite this, put it all together. So let's separate our two problems. It's going to give me x plus 4, x minus 4. That's going to give me x plus 3, x minus 3. That's going to give me x minus 1, x plus 3. And that's going to give me x minus 6, x minus 4. And when I cancel, I'm going to cancel my x plus 3s. I'm going to cancel my x minus 4s. And look at my parentheses, there's nothing left to cancel. So this is going to be one of our larger answers, that being x plus 4 times x minus 3 all over x minus 1 over x minus 6. And that brings us to the end of our assessment. A lot of factoring going on. Hopefully we're able to keep it straight. If not, then we know what we need to work on for Mastery Week. Factoring, factoring, factoring. If you have questions, please bring them to tutoring or ask me during class or class. But happy studying. Hope this helps.